Okay, let's give you guys some practice. So for this sequence, establish if it's going to be monotonically increasing or if it's monotonically decreasing or neither. And also for this sequence, find the upper bound and the lower bound for this sequence. So press pause and have a go. Okay, so to do this, try and glance at this and try and have a rough understanding of what's going on. If you look at this, n to the power of 3 over 2, n to the power of 3 over 2. If you look at the graph of y equals x, it will look like this. So when you look at the graph of y equals x to the power of 1, well, here you've got to the power of 3 over 2, so it's going to be slightly above this. The point here is that as n increases, this thing here will always be positive. It's always climbing. It's always going to be positive. So and also looking at this here, natural log of this thing here, well, your natural log graph looks like this. When n equals 1, 1 to the power of 3 over 2, it will be 1. Natural log of 1, it will be 0. So when n equals 1, the first term is going to be 0. The first term is going to be 0. So for us to answer the question, is this sequence going to be monotonically increasing or decreasing? Let's look at the gradient. So turn this into turn the sequence into a function. So turn this sequence into a function, and then look at the first derivative. By looking at the derivative, by looking at f prime, you can tell if the function is going to keep on climbing or if it's going to keep on falling. So if it always climbs, then you know it's going to be monotonically increasing, and this is monotonically decreasing. Well, first turn our sequence into a function. So this is our function, and then differentiate it. So first, let's just rewrite this. When you natural log something to the power of another thing, well, this power can come down. So that's this bit here, and then now differentiate this. So use whichever method you want. I'm just going to write as one thing to and then multiply another thing, so I can use a product rule now. So let's just concentrate on differentiating this. So differentiate this would be you differentiate this, leave this the same, differentiate it, leave the same, and then plus leave this the same, and then differentiate this. It will then give you this, and then it's blah blah blah, tidy it up, and it will give you this. So it's blah blah f prime. If you tidy up, it will give you this thing here. So now looking at this, when you get to this stage here, you could ask yourself: is the function always climbing? Is the function always climbing? So just by looking at this, is the function always climbing, or is it always falling? Well, here you've got one thing, take away another thing. So if you look at this thing here, natural log of n looks like this. So natural log of n, so this thing here, natural log of n is always climbing. Beyond a certain point, it's always climbing. So this thing here is going to get bigger and bigger and bigger. This thing here is always going to get bigger and bigger and bigger. This has the ability to go all the way to positive infinity. So eventually, this 6 take away a very, very big number is going to enter the negative realm. But when you look at the natural log here, when it's, let's say when it's 1, or when it's, yeah, when it's 1, this thing here will be 0. 0 times 9 is 0, and then 6 take away 0 will be, well, this thing here starts, this thing here is going to be, the gradient will be positive up to a certain level, up to certain points, and then it will become negative. I'm not explaining it very well, but think about it. Looking at this thing here will be, the gradient will be the function will be climbing at first, and then it will fall. So at first this thing here is going to be positive, meaning the gradient is positive, meaning the function will be climbing, and then up to a certain stage, this thing, the gradient, this thing here will be negative, meaning the function itself will be falling. So here you've got it climbing and then falling, so it's not going to be monotonic. So the sequence is not going to be monotonic, because here it's rising. Because if you look at this thing here, I didn't explain it very well, but the combination of the two here, at first is going to be positive, and then up to a certain point, this thing is going to be negative. That means the function is going to climb at first, and then it's going to fall later. So it's not going to be monotonic. I will continue in the next video. Okay.